So myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this class, we are going to study the classification of the gears, that is intersect shafts. In the previous class, we have studied what are the types of gears. The gears are used to transmit motion from one shaft to another or between a shaft and a slide. So this is accompanied by a successfully engaging teeth. When the wheels are having a teeth, then those wheels are known as the gears. If the wheels doesn't have a teeth and transmit motion under rotary condition, rolling action, those are known as the friction wheels. So by considering that the slipping between the two surfaces is zero or no slipping, so what is the kinematic relationship exists between the wheels is that Vp, that is the linear velocity, that equal to omega 1 r1, that equal to omega 2 r2. In the place of omega 1, if you substitute 2 pi n1 by 16 and omega 2 equal to 2 pi n2 by 16, substitute over here, then the relationship obtained is the speed or angular velocity of the wheels is inversely proportional to the radius of the wheels. If the wheel is larger or radius of the wheel is high, then the speed of the wheel becomes low. So based on this principle, the gears are designed, or gear trains are designed, or gear box is designed. Now, let us recapitulate what is the parallel shafts. The parallel shafts classification, there are various types are there. Spur gears. Spur gears, again, two types. One is external meshing, another one is internal meshing. External meshing, both the wheels rotate in opposite direction, whereas internal meshing, though both wheels will rotate in the same direction. Now, it is the rotation of the wheels for internal meshing. This is the internal meshing, and it is external meshing. Now, next category is the spur rack and pinion. Wherever the motion to be transmitted from rotary to translatory motion, this rack and pinion gears are used. So the radius or the diameter of the rack is infinity because it is a straight, it is a translatory motion. And one more thing is that another classification, another type, subclassification of parallel shafts is helical gears. These helical gears having, in comparison to the spur gears, it can transmit more power with less noise, and it can also be used at high speeds. And the contact between the two gears, that is helical gears or helical spur gears, looks like this and transmits motion. But one thing is that both the shafts are parallel shafts. The third category is called double helical or herringbone gears. So this double helical gear is equivalent to a pair of two single helical gears secured together. One having a right-handed helix and the other one is having left-handed helix. The teeth of the two gears are separated by a groove used for tool runout. So axial thrust occurs in this will be nullified, whereas in single helical gear there is a chance axial thrust will be high. And these double helical gears can be used at high speeds and with less noise and less vibrations. Because why less vibrations in comparison to the single helical gear? Because here no end thrust. End thrust will be cancelled out. Alright. So these are very important gears. Now next category classification, that is intersecting shafts. What is intersecting shafts? Here the shafts are not parallel. So the driver shaft and driven wheel, in the before case it is parallel. That is a parallel shafts category. Okay, is a parallel shaft. That's why both the wheels rotate in opposite direction. But here in this case, it is not parallel. Alright. So the motion between the two intersecting shafts, how it happens? Suppose is the driver wheel and the driven will be in opposite direction if you extend the axis. So that type of gears you can see here. So what is the axis? it is intersecting shaft axis. So the motion, kinematically, the motion between two intersecting shafts is equivalent to the rolling of two cones. So assuming that in this no slipping takes place, whereas in the case of spur gears, helical gear, there is a chance of slipping, but in this case there is no chance of slipping. So this is comes under the category. These are the types of or intersecting shafts. Now this type of gears are known as bevel gears. Okay, when teeth formed on the cones, it is a conical shape, are straight, the gears are known as straight bevel gear. Straight bevel gear. And when inclined, and they are inclined, they are known as spiral or helical. Spiral or helical bevels. If it is a straight, it is straight bevel, and there is having a spiral or having inclined, they are known as spiral or helical bevel gears. So that is the bevel gears. Now we can see the straight bevel gear. The teeth are straight in this and radial to the point of intersection of the two shaft axes and vary in cross section throughout their length. So their cross section varies. It is not same. We can see here it is like a cone shape. The cross section here at one end is different from at the other end category. Okay, it is a cross section here. It is A1 and cross section here it is another one, that is A2. In between there are so many cross sections. Okay, understand? So the variable cross section gear. These are the straight. But why it is a straight bevel gear? Not based on the shape straight. The based on the straight teeth. If the teeth are straight, then it is known as a straight bevel gears. So these straight bevel gears are used to shafts having at right angles and can rotate at low speeds. Okay. And one more thing, what is meter gear? The meter gears means having a small size and connecting two shafts at right angles to each other. Gears are of the same size, both gears are having same number of teeth and it is in small, same size and connecting at right angles to each other. Then those type of gears are known as MITRE, meter gears. These meter gears comes under the category of intersecting shafts and also comes under the subcategory of straight bevel gears. Okay, straight bevel gears. One more thing. At the beginning of engagement, these gears, the straight bevel gears, make the line contact similar to the spur gears. It is like a line contact, exactly similar to the spur gears. And if you want externally operating, both the wheels rotate in opposite direction when there is external mesh. For internal mesh, if you want to rotate in the same direction of a driver and driven gears, they should have a contact of inner contact or inner meshing. So those internal contact bevel gears are known as this internal bevel gears. It is similar to internal spur gears. Okay, in the same direction of rotation. So if there is external mesh, both driver and driven gears rotate in opposite direction to each other. Whereas for internal contact gears, then internal meshing gears, both the driver and driven gears rotate in the same direction of rotation. Now these are the straight bevel gears. Another type of intersecting shafts is spiral bevel gear. What is the spiral bevel gear is all about? Here we can see the spiral shape. These are the spirals. One thing here, the coefficient of friction, the grip or meshing grip is higher in the case of spiral bevel gears. In the straight bevel gears also, the power torque transmission is high in comparison to the spur gears. But more, that is called straight bevel gears. These spiral bevel gears are more powerful or more strength. More torque can be transmitted in this spiral bevel gear. And in the spiral bevel gear, very important is that these spirals are known as also we can call it as a helical bevel gear. When the teeth of a bevel gear are inclined to an angle to the face of the bevel, they are known as spiral bevels. You can see the spirals, how it is. It is not straight. It is having some curvature is there, but still it is not straight. Some inclination, like that straight, as we have seen straight bevel gears. So these, what are the application of this type of spiral bevel gears? It is used in differentials of an automobile. Differentials of an automobile. These are used to drive differentials. So these spiral bevel gears are used in differentials of an automobiles. Okay. Now, where it will be differential in the case of automobile, the four wheels. If you consider, these are the front wheels, these are the front, and these are rear wheels. So here it will be the differential. So this is the position where differential is, and here it is engine shaft is connected to differential from here, and it is here another transmits motion. So these are used for spiral bevel gears are used for differential categories. And here it is zero bevel gear. Zero bevel gear means spiral bevel gears with curved teeth, but very important, with a 0-degree spiral are known as a zero bevel gears. If it is even the spiral bevel gear, there is some inclination in that. In this zero bevel gear, it is a zero bevel gear. So it is a 0 degree. It is a 0 degree inclination. That means no inclination, but a spiral. Then it is known as zero bevel gears. So their tooth of action, you can see, and end thrust are the same as that of straight bevel gears. So it is the same. These type of gears are used as usual as the straight bevel gears. Okay, same mountings. And also very important is that at high speeds it is having a straight bevel type, so it is quieter in action. Is the more grip is there and not more grip, the more high at high speeds these bevel gears can be used, and the slipping action is low in comparison to the spur gears. That is called parallel shaft axis. In the case of parallel shaft axis, that is called spur gears, there is a chance of slipping along the axis of the shaft. So because of the parallel, because the teeth are straight in contact. In this case, the grip, the contact, the external meshing, the contact between the driver bevel gear to the driven bevel gear is having contact. That contact is such a way those gears can be used at high speeds, and with at the high speeds these gears will give less noise and low vibrations in comparison to spiral gears or in comparison to spur gears. And the manufacturing is in relation to the spur gears. High skilled worker is required to fabricate this zero bevel gears in comparison to spur gears. And one more thing, the coefficient of friction is higher in the case of zero bevel gears in comparison to spur gears. In the case of spur gears, if there is any thrust along the x-axis, that thrust causes to slide the gears from meshing position to. That's why wherever spur gears are there, at high speeds, there is a chances of slipping between the gear wheels. So in automobiles, at the spur gearbox consists of spur gears contact. At high speeds, what will happen due to the period of wear and tear? There is a slipping of gears takes place. Without, generally, if you want to change the shift the gears from gear 1 to gear 2, gear 2 to gear 3 through to 4, we have to apply the clutch. By engaging the clutch or by disengaging the clutch, we have to change the gear and we have to engage them. My point is that what is happening here, without applying the clutch, the gears will be transmitted, the speeds, automatic gear 1 to gear 2, 3 to like that, automatically. It is not automatic transmission of gears. It is wearing off. Due to wearing off the gears, this shifting takes place from gear 1 to gear 2. Okay, that is because of what? Spur gears contact. There is a chance. But these type of gears, zero bevel gears are there. Okay, in this zero bevel gears, that such type of slipping is low in comparison to spur gears. And one thing, if axis or it is in external contact, the driver and driven bevel gear, it will rotate in opposite direction. If one wheel is rotating clockwise, another wheel rotates in anti-counterclockwise. It is in opposite, not in the same direction. To obtain the same direction of the motion between the driver and driven wheels, we have to contact, or there should be inner contact between the wheels, as we have seen in the case of spur gears, internal contact. Now these are the zero bevel gears. There are certain terms are there. The terms are that, what are the terms are used here? One more thing. In the case of gears, between the two teeth, there will be a length of path of contact. There will be contact between the wheels. That contact is denoted by with the different terms. That is length of path of contact. And it is in the form of arc, then it is known as length of arc of contact. And one more term is called contact ratio. These are all depends, or for effective performance or having better torque transmission between the two wheels, that is the gear and pinion. A larger wheel is known as a gear and a smaller wheel is known as a pinion. For effective grip, unless and until there is a proper meshing takes place, then there will be chances of slipping between the two wheels. In order to understand that contact is so important between the driver wheel teeth and driven wheel, both the teeths, that contact having, in order to measure, quantify the torque transmission, there are certain parameters are there. Those are known as path of contact, or length of path of contact on driver wheel, or length of path of contact on wheel, and length of path of contact, length of arc of contact on wheel, and contact ratio of the both wheel. Now here, contact ratio of the wheel. So this is only related to the gear. Where is the pinion? That is length of path of contact of pinion. The same parameters will be repeated to pinion also. So this pinion means smaller wheel, gear means larger wheel. We will study in this chapter how the length of path of contact, how the interference takes place. One more thing, before going to find out or study all the things, there are certain terms are used. What type of terms we have to know it. In the case of in gears, certain terms are, that is, one is addendum, another one is dedendum. And addendum means it is the radius by touching on the surface of the teeth from the center of the wheel to on touching the surface, that radius is known as addendum. Suppose if the teeth, it is teeth. I am considering here only single teeth, the center of the circle. This is the radius, is the maximum radius. This is addendum radius of the wheel, RA. It is the wheel gear means R, capital RA, capital RG, capital RA. That is called addendum of capital R. That is the radius of the gear. And dedendum means it is a downward circle, downward touching. It is not a root. Root is different from dedendum. Next, another circle is another one term is called module. This module is denoted by M, that M equal to D by T. Okay. And there is another circle is called pitch circle. These are the terms we have to know in order to do or study the contact, length of path of contact and the length of arc of contact or contact ratio of various gears. Especially we will consider in this topic is gear and the pinion. Between gear and pinion only. The gear is the larger wheel and pinion is the smaller wheel. This module M, module small m, that equal to D by T, where D is called small d by T, small d by small t, or capital D by capital T. Now here what is the D? That D is known as the pitch circle diameter by number of teeth. Is T means not one teeth, that is number of teeth. And one more important is that this module, in order to while purchasing the gears outside, there are certain parameters are there. What is the size of the gear? The size of the gear is represented with the help of number of teeth on the gear. And one more important parameter is called module, M, capital small m. This M is the ratio, that is M equal to D by T, the pitch circle diameter. It is denoted with what is the 14 mm, what is the module and all. Yes, another one more important is the pressure angle. As we have studied the pressure angle in the case of cam drives, here also pressure angle we will study. Okay, these are the terms and classifications you have studied now. The classification you have studied in this gears is called, that is class number 2, that is called intersecting shafts. The intersecting shafts, number 1, straight bevel gears. Under bevel gear there are two types. One is straight bevel gear, another one is spiral bevel gear, and second one is zero bevel gear. There are three types of intersecting: straight bevel gear, spiral bevel gear, and zero bevel gear. So these are the, and comes under the category of intersecting shafts classification category. So these are all only classification of gears. These are not classification of gear trains. The gear trains are different. Those gear trains are comes under, it is a simple gear train, compound gear train, and reverted gear train. There are types of gear trains. Gear train means the number of gears are connected. In between the driver and driven gears, there will be intermediate shafts, intermediate gears will be there. That whole family of the gears is known as the gear train. Okay, it's not like a train means the number of coaches, not only engine. If there is only engine, that is called train engine, loco engine. We should not pronounce it as a loco train. The train means number of coaches are connected to the engine. Similarly, in this case, gear train means number of gears are connected in order to obtain the required speed and mainly required speed of the driven gear. So those gear trains, types of gear trains are different from types of gears. Gear train is one is simple gear train. Simple gear train. Second one is compound gear train. Third one is reverted gear train. So these are the various types of gear trains. Okay, that one is different. Here gears are different. Gears are not a train. It's a single types of gears based on the parallel shaft. The two shafts are parallel. Then those comes under the spur gears. Okay, rack and pinion. One more thing, the helix angle, single helix, double helix, and herringbone gears. And these intersecting shafts gears are straight bevel gear, spiral bevel gear, and zero bevel gear. This spiral bevel gears are used in the case of differentials of an automobiles. Now, the contact between two teeth is either point contact or line contact. Then, according to concepts of kinematics of machines, those pairs are contact. Two gears means one pair. Those pairs contact comes under the category of higher pairs. For higher pairs, coefficient of friction is low in comparison to lower pairs. Lower pairs, the friction is high, very high. Friction is very high. That's why, and less transmission of the power for higher pairs. Here we can transmit more torque. That's why we use it here. And chances of slipping can be avoided, can be reduced completely in using the gears. And one more thing, very very important point is that these gears are transmits power by direct contact. It is not indirect. Why indirect contact means if there is pulley drives are there or belt drives, it is not a direct contact. The power is transmitted from one shaft to another shaft through the belt drive or chain drive. So these are the different concepts. Those are called belt drives. But in the case of gear trains, the power transmitted by direct contact each other. By direct contact to each other, in this case the power will be transmitted. And so one more thing is that, so these gears are okay. And how to find out the speed of the gears? There are various methods are there. So these gears, we study the topic of the gears. Number one, tooth gears. Number two, gear trains. In this gear trains, we study the speed of the gears. Speed of the gears of various gears. Okay, as we have seen that simple gear train, compound gear train, reverted gear train. One more train is called sun and planet gear train. Those are all only will calculate the speed of the various gears by considering speeds of the gears and number of teeth on gears by using simple formula, that is gear ratio. By considering the gear ratio formula, okay, or velocity ratio, we'll find out gear ratio. Velocity ratio formula, what we will do, we will find out the output speed, what is the required speed of the gears. That method, in order to find out the velocity and speed of various gears, we'll use, there are two methods are there. Number one, analytical method. And second one is a tabular method. Number one, analytical method, and the second method is tabular method. This analytical method are used, both are used for calculating the velocity ratios of the gears. Now, coming to the topic of toothed gears. In the toothed gears, we will do more analysis part. It is related to the design of the gears. What is the design of the gears means? What is length of path of contact? Length of path of contact, length of arc of contact, contact ratio. One more important is that called law of gearing. What is the law in order to meshing? So these are the things we study in this category. These gear trains are application oriented, whereas these toothed gears are analytical oriented. But these toothed gears are useful to design the gears. Unless and until designing the proper gears are not designed properly, we cannot obtain the proper output, that is the speed at various speeds and number of teeth. These are all. So in fabrication, the most important is that these are the gears will be based on the application. We go for the type of the gears. The requirement of the gears are at high speeds, direct contact power transmission is required. With more power, more torque, we have to go for different types of the gears. So it is not like spur gears are used everywhere, rack and pinion is used everywhere. No. Wherever the required application highly necessary, where we have to select the type of the gear. And the gear materials are different types of gear materials. By using 3D printing technology, these gears are fabricated with the help of that nylon 6 materials. Those using that is polymer materials, we can also fabricate gears. We can also print gears by using that is in 3D printing. That is called another. That subject is known as additive manufacturing. Additive manufacturing. Okay. So these gears can be fabricated with the different materials. Okay. And one more thing is that gears are highly useful to transmit more torque without any loss of power from input shaft to output shaft by direct contact. And one more thing, it occupies less space in comparison to other drives. Other drives means belt drives and chain drives. And one more disadvantage is that if you want to transmit power from longer distances, these gear drives, we need a number of gears. Trains are required to transmit power. That's why at that time we go for belt drives. So these belt drives and chain drives, these chain drives are usually to transmit from rear wheel to front wheel or rear wheel to gearbox in the case of bikes or for two-wheelers. Now point is that, and if you want to belt drives are used where the transmission power is, if you want to transmit power for longer distance. That's why in case of rice mills or paddy mills, belt drives are used. Belt drives. So some advantages, some disadvantages are there for everywhere. But one thing is that what is our requirement? Based on the requirement, we select the drives. Whether gears you have to select or belt drives. Gear trains or belt drives. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.